Hi. So, like I said, I promised disclaimers. Number one, I dropped out of linear algebra. So, if the math is not mathing, askis. The second one, this being an AI talk, it is mostly generated by AI. And this talk is not about JavaScript, like for real this time. And lastly, I swore I wouldn't do this again, but it's nice being on stage. Like the lights are on you, and it's just this might be the high point of my life. It's just might be it. Cool. My name is VT. I really never say my name. No one else says my name, but it's pronounced Vutlhari Rikhotso, and that's exactly why I go by VT. My official role is principal consultant, but I know consultants get a bad name. So because I'm constantly acting like I know what I'm doing, I've decided to go by principal intern. I work for Demon. I'm edgy, so I'm not really on social media. So if you want to reach out to me, you can visit vtcodes.dev. I swear that by the time you visit the link next week, when you remember this talk or when this talk goes onto YouTube, I will put some social links. If you haven't already told by the big bad signal at the back of my jacket when I'm not in this hot room, I work for Demon. Demon is a tech consultancy based in the UK. Our vision is to make the world a better place through technology for real. Like, look at our odds. We're a great place to work, and our main goal is to leave our clients enabled. So our entire thing is that we go in 3 months, 6 months, and we're out. And if the clients are not enabled, then I failed, right? Which goes to my job, right? Again, principal intern at Demon. Demon has three practices. The first one being the cloud practice. So, you know, I fall in that because I have AWS certifications. There's the data, AI, and ML practice. We've got the digital engineering. So that's the stuff I'm known for, writing very bad JavaScript. But recently, I've been working on the data, AI, and ML because, like I said, intern. So anything that happens, I'm in there. Last year, September, I was put on a project with a company named Conjecture. They're an AI company. Every company is now, right? They do a few things. So they have chat products. They've got a product called Axiom, where you can talk to a chatbot that takes on different personas. But they also release a bunch of products, like one called Cubed. So what Cubed will do is, after your Scrum Master has done the great work of putting together a Jira ticket, it will go into Jira and it will basically kind of put pseudocode for you, right? On that ticket, like, here's an example implementation. You might want to import this package and that package. So that's what they do. And then they have another one called, I think, Super Cubed, which is inside Visual Studio Code. And it will actually go write the code for you, right? So you don't have to do anything. Like, your Scrum Master writes Jira, Cubed goes pseudocode, and then straight to code. And then you just only have to spend a couple of hours debugging code that was written by AI. But at least you didn't have to go to ChatGPT to generate it, right? So when they came to us, I was given a task, VT, intern, can do anything. Like, do you know AI? Of course, I've done AI. I know AI, I know ML. Have you done in math? In high school, but yeah, dropped out of linear algebra, but it's okay. Like, I can do AI. And they came to us and they're like, okay, cool, we need help. We have foundational models. I learned what foundational models are last year, September. Built foundational models and we deployed on our own infrastructure. And we need help moving it to AWS because cloud, right? And then I got interested and I started finding out, what's the big deal with AI? Is it another crypto thing, which I ignored? Only thing I regret is not buying enough Bitcoin. But according to the Fortune Business Insights, the machine learning market is expected to grow from 20 billion in 2022 all the way up to about 200 billion by 2029. That's in 5 years, right? So that's 10x. It means that there's a big market. And as a consultant, I chase markets. And then I found another very concerning stat. about 87% of data science projects never make it into production. What that means is that there's a whole bunch of Jupyter notebooks out there that are suffering the same fate as my startups that are sitting somewhere on GitHub. I'll launch one day, I swear, after launching the social links on my website. And then, like, okay, cool. So 87%, big number, 200 billion US dollars, also big number, right? Why is it? Why are people not launching? And then I'm like, it must be very difficult to basically create machine learning models. And I found out actually creating predictive ML models is getting easier. And we just didn't know because Sam Altman had not launched ChatGPT yet. And when he did, like, oh wait, actually, it's just need like Microsoft level backing, and then you can create your own models, right? And I wanted to find out, okay, cool, how does all of this work? Cool. So there's a few steps involved. I've highlighted one in green because, again, the first two steps always get done, right? Jupyter notebooks. The last step is the one where it doesn't happen very much. So, but let's back up a bit, right? So roughly there's about 3 steps. The first step is your model development. So that's where you go and you create the model, right? How does that work? You get your data sources. You have your very smart data scientists looking at, they already have the Jupyter notebooks done. So you don't even, as a business, don't even need to invest. Just ask them, yo, can we see your Jupyter notebook? And then basically what they do is that they collect a lot of data. In this talk, the example I'm going to use is a call center, because I spent a year working in a company where we had a very active call center. And I found out that call centers record every call. They're not lying. And also you get a lot of not really great calls. So where someone's just asking something that could be answered if they just visited the website, right? Opportunity for automation. So what you do is your data scientist will go and collect data. It will be mainly in spreadsheets, CSVs, some databases. There will be Redshift there, Oracle there, and a whole lot of different things. And then what they do is that the next step is that they'll do a lot of cleaning of the data because it needs to be shaped right in order for us to go to training, and we'll cover what training actually means, right? Excuse me. And then they'll do a bit of training and validation, right? So in very simple terms, in my non-linear algebra passing brain, this is how training works, right? What you're doing is that you're trying to teach a machine to identify patterns, right? So if we were to take a naive example, you might have it's raining cats and dogs, right? You know that because you've had that saying before. What will happen is that a machine will be trained on a lot of data, and the most likely term is probably going to be dog, right? There might be other terms, but then the machine is going to guess that the next word is probably dog. And that's what's basically happening, is that there's so much data, too much for you as an individual to fully like understand the patterns, and you pass it to a machine. With very smart people have done a lot of the machine learning algorithms, all different kinds, and then you're able to use those algorithms to basically train your data to identify patterns. And then lastly, before that, actually, people will do feature engineering and model decisions. So they'll basically find like, common things in the text that they want to train on. And it might be, for example, shopping patterns for your e-commerce store. So your data scientist will basically find something to latch on and use that to basically train your models, right? The second one says retrain, right? Because after this, typically what's supposed to happen is you deploy your model. By deployment, it means that you make it available for other people to use, like you use ChatGPT. So what OpenAI has done is that they've deployed that model and they've created a simple interface for you to work with. You use that. What happens is that sometimes ChatGPT will hallucinate. So it will make up things. It's very bad at math, just like me. So it can't help me there. So if anyone has any recommendations for large language models or anything AI that can help you with math, appreciate it. So what will happen is that once you have that, you might have, for example, a prediction service as we're using here. You'll query that, and then it'll, I try to create one where like here are all the lotto numbers that have ever existed in SA. Here's a date. Give me the next one. I've never won. I've tried multiple times, just not happening. So unfortunately, I still have to be a principal consultant. After that, you get feedback. If you look at ChatGPT, you might see it says like, "Oh, this answer is not very good," right? So what happens is that might go to human evaluators to go see, and then basically use whatever they learn from that to retrain, right? So that's roughly like the process of how this AI thing works, right? The first two, data engineers and data scientists, are very good at. The last one seems to be the stumbling block. But here I was, bad at math, never done AI before, and now I have to do this because I've written some JavaScript in my life. Cool. So call centers, right? How does the AI journey work? So if we go back to my example where we are working with a call center, a lot of people are calling in. I didn't receive my order. My order was broken. I don't like this product. Doesn't look like what it looked like. Why did I have to pay all this tax? All those things, right? So you might say, okay, fine. I think so much of our calls are about a certain thing. So your data scientist might go and do some exploration and say, actually, it looks like roughly 80% of our calls are about things that are available on our website, and people don't want to, people don't want to actually read them. So maybe we can leverage some automation, right? So what can we do? First is, can we get a robot or an AI to talk to a person, right? Cool. What does that look like? It means that a person has to talk into a phone. You have to take their voice and convert it into text, right? Because then an AI can understand text. Large language models are very, very good at natural language processing. That's like the entire magic behind it. And then next, it might be like, okay, cool. I need to understand the person's intent, right? They're calling about billing. Are they calling about something else? How do I route them to the right kind of thing for them to look at? After that might be sentiment analysis, right? We know that people who call centers are not calling to wish you a happy birthday and tell you how nice their dog is and all of that. Usually people are angry. So if we're going to automate, it means that we need some escape hatches. So it might be like, oh, if a person, we're detecting that they're angry and they're not happy with the conversation, we might want to route them to a real human to talk to. So that would be something like sentiment analysis. And at the end, you might have, call summarization. So as the manager of the call center, you might want to know how a call's going, right? So if VT just took a call from a customer, the call was 15 minutes, and that's kind of all I know. I need to know if VT's tone was good, if VT followed the script, if VT was respectful to the clients, stuff you can use AI for. And also, because you want to be able to answer people, you might have a knowledge base, right? So your Confluence, your training documents, all of that, feedback from retros that you've done and never actually did anything with the information. And lastly, you want to get the machine to talk to the person. So you want to take all this text that has gone through all these different processes and basically turn it into audio that can talk to a human. Cool. Still on the same page? Cool. So when you look at this and you're like, how do we solve this problem? I think for speech to text, we can use, Sam Altman was kind enough to release Whisper. It's open source. So you can, run it on your local machine. I did last week just to make sure that the stuff I'm talking about can actually work. It took me a long time, but at the end of the day, it was quite easy. And there's very nice ways of working with that. Cool. Then we look at intent recognition, sentiment analysis, and call summarization. Remember, I said if there's one thing that large language models are very good at, is things to do with natural language processing. So things like text classification, feature identification. So that's what you'd use for things like sentiment analysis, recognizing intent. You don't have to use ChatGPT or GPT-4 or Mini or all of that. You can have Llama. It's also available on your Instagram. On the search box, you can ask it, what is Llama? I don't answer. Then next is your knowledge base. So how do you embed your knowledge into the model? Because remember, these are very different things. So turning speech into text is an independent thing. Understanding intent and all those sorts of things done by LLM is a different thing. Having a knowledge, you can't just say LLM, here's my link to my Confluence, answer the question. So if to do something called vectorization, I dropped out of linear algebra, so please don't ask me to explain, but basically what the machines do, they create like a whole world with your data using something called features and vectors and all of these things. So basically LLMs are able to interact easier with that representation of data, where it has context to be able to build things. So to do that, you use something called an embedding that you might want to put into your there. And lastly, we want the AI to talk back. So we'll basically get our stuff, put it into LLM generates a response, and then we say, okay, cool. Voice generating model want to stream a response back, and then might be using something like Mozilla text to speech. Still same page. I can't see anyone, only Lauren judging me in the front, so it's very difficult. Cool. So now that we understand what we want to build, we've kind of identified 3 models and embedding that we want to look at. We need to look at deployment methods, right? So by deployment methods is like, how do we actually, what method works best for our use case, right? And therefore that I know of. So if you know more, I'm sorry, I'll add it in my next talk. The first one being batch. So I'll explain what that is. The second one being real time. The third one is streaming. And the fourth one being edge. And streaming, I don't mean like what ChatGPT does, where it basically kind of writes back. That's a different kind of streaming. In terms of deployment methods, that's a completely different kind of streaming as well. So first, batch. Let's look at what that looks like. So basically, a user will request prediction. So, VT says, yo, next week's lotto numbers. Excuse me. And then the backend written and whatever, you can write, your flavor. You can write JavaScript, you can write Python, you can write Java. I don't know why you would, but you can write Java. And that will pull predictions from a database. But what do you mean database? Where does this come from? So with batch, what would normally happen is that you're actually processing your data daily. So imagine there's a whole lot of things happening in your e-commerce store. People are buying different products, and you want to basically figure out what your next recommendation, like recommended products look like based on volumes from the previous day. So, midnight, everyone's sleeping and hopefully not internet shopping. You process a batch, and then you put that, your predictions in a database. This does mean that data can become outdated, but the good side of it is that it will only be as outdated as the last batch process. So what that means is that best case scenario, you maybe about a day or a couple of hours outdated. Worst case scenario, batch didn't run, but if you run it again, then you kind of back up to date. So the first one doesn't kind of work for us because I can't ask, why did you debit this much from me and then have to wait an entire day to get an answer, right? So that takes us to the second one, which is real time, which is what we've all come to expect of LLMs, like ChatGPT. I have an assignment due in 8 hours. What does this mean? And then, so user requests the prediction, and instead of now talking directly to the database, basically we talk directly to the ML service, and that will basically respond to you. But it might be pulling data that's stored on the database as well to figure out some stuff and respond back to you and serving you with a prediction. So the nice part of this is that it generates personalized predictions most of the time based on recent contextual info. So if you imagine you're using a service like Netflix, you might be searching for a movie that unfortunately Hulu won't allow Netflix to have, and Netflix doesn't want to lose you, so they use that information to recommend a movie that's similar to what you search for, right? Such as other shows to keep you paying, even though they won't allow you to share your password with your brother, right? So again, and the problem with this is that you have a lot of people dealing with your system, expecting answers in real time. And that's why sometimes if you don't pay the $20, ChatGPT might be like, yeah, you've kind of done enough now, because what's happening is that basically your servers are on fire, servicing millions and millions of people that are brain rotting because they ask ChatGPT for this. Well, listen, how do I write a for loop? You can just go to Stack Overflow. The third one is streaming. Like I said, with streaming, so this is a bit different. So now the model doesn't come into effect immediately. Remember, with real time, I ask it something, the model has to get it to work now. But this time around, I think an example for this might be if you use a service like Zencaster, where you record podcasts. If I didn't say I record podcasts, after recording, it might trigger that, okay, I want to transcribe my podcast. So batch doesn't work in that case because it means that, like, you'll have to wait an entire day to get your transcription. So what those services will typically do is that they'll write this into a queue. So using something like Kafka, using something like RabbitMQ, and then when the your model service has capacity, it'll pick up something from the queue, process it, and basically write it back into the server. And you might get an email or notification that your transcription is done, right? The nice thing about this is that the prediction is triggered by user action. So I just finished recording the podcast. I want a transcription that does that for you. And actually, this is a lot of what recommendation systems are built on, where it will go, you'll do a whole bunch of stuff, and then it will, write it into a queue, use that information to basically try and recommend stuff for you. The good plus side of this is that it reduces server processing burden, because then the machine learning service will pick up a job when it has capacity to do so. And it means that you optimize for your compute, right? Because if you can afford 5 machines to do this, then you can spin up 5. If you can only afford 1 or 2, you only just spin up that, and people will just have to wait depending on that. This doesn't work for our use case, again, remember, because calls real time. So streaming not really good for us there. And the last one is edge deployment. So you might have seen, for example, your phone might be categorizing your photos. So you might be able to go into your Photos app and search for bus, right? And then your app does that. There's a lot of privacy concerns there. So what would typically happen is that your phone manufacturer will deploy like a small model on device, or you can buy like a lot of the other devices, even though I think things like the wearables now are using remote things. But basically the idea is to be able to run like inference on the machine there. So user requests something, and then it requests like the data from like locally, it will serve that. But then basically the model might get updated by being able to kind of send requests to the server to get contextual information, to be able to could not identify cat properly, and now I've learned, so like this is a photo, it said it was a dog, retrains kind of feedback into your phone. The advantage of this is that it can be deployed on the client's device, and it also means that you typically get faster results, and you also can have offline predictions because the model's running locally there. But the problem is that the models have to be really, really small. I mean, our battery life is already, what, 4 hours? Cool. So if we review that, we've got batch, we've got real time, we've got streaming, and we've got edge. But what we're trying to do is trying to automate call center work. So the best choice for us there is real time. So decision 1 is done, right? What deployment method are we using? We're using real time deployments. The next one is hosting. So cool. We know it's going to be real time. We can't deploy it on your phone. Maybe you can deploy it on a Raspberry Pi, but Escom, lose internet, it's just also the number of people probably calling the service are a lot of people, right? So typically, to be able to deploy anywhere, as we discovered as an industry a couple of years ago, people containerize applications. The same thing happens with machine learning models, right? So typically what would happen is that you'd have an external artifact store, because when a machine learning model boots up inside a container, what it needs to do, it needs to download what are considered model weights. So basically the training produces some numbers, those numbers, number of parameters. So if you hear things like llama, 7B, it means 7 billion parameters. It just means basically number of kind of different numbers that the machine is using to identify your words. So typically you'd store that somewhere externally. You might find it on Hugging Face, but since we're talking about AWS, you might be storing that in an S3 bucket. So that gives you the security of being able to like kind of control access to your weights, because typically what people do is that they'll go and find a model, then they'll go and do what is called fine tuning, which is a very expensive exercise. Sometimes you need a lot of data, and sometimes you need human workforce to go and label data. This is cat, not cat. This is cat, not cat, right? And then basically say, okay, these are my custom weights that is an improvement on the public weights. I want to store that securely in my own artifact store. The next thing is that those weights will be used by a model. So in this case, you're using like the Whisper one. So Whisper is the open source model from OpenAI that will basically do transcriptions for you. And then what you'll have is your inference code. Python people love fast API. I think there was a talk about if fast API is actually fast. But typically that's what's used. And then what you'll do is that you'll have these two things and you basically put them typically in a Docker container. And then you'll host that somewhere on instances that support compute. Typically, LLMs require GPUs, so it's not just any instance. That's why I'm specifically calling out ML compute instances. So again, hosting on AWS, you've got a couple of options. You have way more than this, by the way. So there's already ready to go AI. So for example, if you want to do image recognition, I think you can use a service aptly named Recognition on AWS. If you are, trying to do things like, for example, text to speech, I think you can use Poly for that. So there are already built services that you can use. But what we're talking about here is deployment at scale, right? Where you don't want to pay crazy prices. You want to have a bit more control on how you deploy, but you also don't want to have to pay a heavy cost of acquisition building together a team. Cool. So EC2, basically, this is just a server in the cloud. It's a virtual machine. It's virtual because it's not sitting under your desk, but it behaves basically like the same way. This is scalable in the cloud. Typically, they're affordable relatively. It means that when you run out of server space, you don't have to go to a physical location. You can quickly spin up something. You don't have to go through procurement in the company to go buy a server and wait to get someone to set it up. So this does mean you get full control because it functions just like a server that you'd have under your desk. It also means that like you can basically go as crazy as you want around the configuration. So you can install whatever you want to install on that VM. But it does mean that you require a lot of like manual management. And that's why we moved to the cloud in the first place, so that we didn't have to do that, right? We didn't have to learn how to do actual ops. And it also just means that there's no built-in ML tooling in the instances. Secondly, we have EKS, which is AWS's managed Kubernetes service, Kubernetes U. This means it can support very like complex deployment. I mean, like Kubernetes is, if you went through the pain of actually setting up Kubernetes, might as well use it. I mean, like all that knowledge going to waste. But typically, I found this a bit too complicated for what you want to do. It also does come with a bit of an extra fee on AWS to like do the Kubernetes management. So you've got the overhead of the Kubernetes management. Again, no built-in tooling, but a bit more control. If you, for example, already have a Kubernetes cluster, you might be able to reuse some of that for your deployments, right? Cool. As AWS does, it has an alternative to Kubernetes that is just slightly cheaper, but also just slightly less capable, which is the Elastic Container Service. So this, again, it just allows you to deploy containers in the cloud as Kubernetes does. This is much easier to manage compared to Kubernetes because it doesn't come with like a lot of stuff gets done for you, and a lot of the parts of it that you use, like, assume a few things. It also means that you've got crazy good, interaction with AWS services already. So for example, if your model weights are sitting in S3, it means you can get that. You probably want to do some sort of metrics and logging and understand how, requests coming to your tooling. It means that you get like native integration with services like CloudWatch. This does mean you've got even way less flexibility as you would on Kubernetes. And again, no built-in ML tooling. And lastly, you've got SageMaker. Actually, this entire talk is about SageMaker. like just to be honest. So SageMaker is a fully managed end-to-end machine learning platform. It means that you can do everything from like your first idea. You don't even have to have Jupyter notebooks in your local machine. You can spin up like, a SageMaker studio. You can do all sorts of things, basically from idea all the way to production. But in our case, we look at it to say, okay, fine, this is purpose built for machine learning, and it's got automatic scaling and optimizations built into the service. The downside of it is that you again get less flexibility. I mean, they are improving the service, but it means that it's custom built to do a specific thing. So an example with when we worked with Conjecture was we had to do some jiggery pokery to get WebSockets working, because SageMaker will spin up the instances for you, to set up the load balancer and all of that. And so you don't, and it really could be running anywhere. So you don't have an easy way to manage that as you would if, for example, you used EC2 and used like, sticky sessions and be able to kind of like do that kind of thing. So it is less flexible, and it is also higher cost at scale. It is improving. So again, I said cheap, but then it's higher cost. I think you can you look at the different costs. So an instance on EC2 will be about 20% more expensive on SageMaker. But typically what that means is that because a lot of the management happens, it means that you don't have to, again, take on the cost of hiring a team to go and manage instances for you. So I think when you work it out like that, it actually does work out cheaper in most cases. So that's our chosen option. We're going to use SageMaker. But this is a slide I added about half an hour ago, which is Bedrock. So AWS is another service which is very, very similar to SageMaker, but that's AWS, right? It has services that are similar to other services that are, geared towards different people. So Bedrock is, if you're a developer, don't really care, you just want to get something working quickly, just via APIs. That's the service you should look into. But for our use case, we wanted a bit more control. We wanted, again, remember, we want to keep it cheap, we want to keep it affordable. So we choose SageMaker, right? So our choices for the deployment method, we've chosen real time. For the hosting, we've decided to work on SageMaker, right? Still on the same page? Cool. Then you've got a couple of options for hosting real-time inference, and we're specifically focusing on real-time because that's what we've chosen, right, on SageMaker. So there's what we looked at, where you build an entire container, you download a model, offline, you put it, you write some Python code, all of that. So that's like you basically bring your own container. The only thing you need to do here, and I say the only thing, like it's you need to make sure it's compatible with SageMaker. So what that means is that it needs a ping endpoint, it needs an invocation. So for example, you might, your transcription service, you might have a transcriptions endpoint. You'd have to call that invocations basically for it to be supported inside SageMaker. Above that, so you do everything, right? You put in all the code that's required. Above that, you've got optimized containers. So in this case, you'd typically be supplying your model weights and some sort of config code. But SageMaker is managing a lot of that thing for you, and you don't have to build a Docker container. You just have to provide some code. And again, the requirements become less and less as you grow up. So, for example, you've got framework containers that you can use, and also you've got built-in algorithm containers where the only thing that you need to supply is the model weights. I think for us, that's something that we're going to choose, because then we don't really have to go through the process of building containers. Then there are about 4 options. There's a secret 5th option at the end. Spoil the surprise. Where you can host a single endpoint. So that means that one container, one instance, right? One model. So if you have, for example, like Llama, it's in that instance. And depending on how much of that compute of the instance you need, that's it, right? If you're not using 25% of it or 75% of that capacity, is just there, it's sitting idle. The second one is multi-container endpoint. So this is where you can have, your different models sitting in different containers deployed on the same instance. The problem with this is that you don't have dynamic instance selection, So it means that in cases where, for example, your speech to text model requires slightly different things than your like your large language model, you don't get that automatic thing. It means you still need someone to kind of go do the work to put things in the right place. The third one is the multi-model endpoints. So what you get here is that you can basically host multiple models in one container, right? And lastly, you've got serverless, where you don't have to spin up anything, right? So very, very attractive, because again, serverless is the hero, right? Saves us a lot of money. But the problem with this is that you have no GPU access. So typically making it not worth it for large language models, but might be worth it for other models that you want to consider and work around on AWS. So for our use case with the call center, we're going to focus on single endpoints as well as multi-model endpoints and look at what that looks like. So you might have, for example, like a Llama 2 13B model, right? I learned this last night, like what it actually means. But it's just, but I speak like an expert now. Llama 2, 13 billion parameters. The first thing you want to do after you've identified your model is that you need to go and do some calculation, right? Because how do I know how much compute I need, how much memory I need for that specific model that I need to do? There's a calculation for this. So basically, you typically just multiply your number of parameters by 4 bytes if you're working in a like a floating point system of FP32. So for example, for this specific model, you'd need 52 gigabytes for just your model weights, right? And then large language models usually have something called attention. So what attention is that basically you're telling the machine not to treat everything basically in your request as equal. So it keeps track of what's the most important contextual word. So for example, if you have, it's raining cats and, it might be like, raining, and cats might be kind of have a higher weighting. And of course, because when you look up at all the data that's been trained with, cats might be closer to dogs, and then it's more likely guess, that type of thing. So typically for that, you might need another 4 to 10 gigabytes. And then for any additional overflow, you might need maybe another 2 to 3 gigabytes. So you're looking at about, I think, 65 gigs. I said I'm bad at math, so if I'm wrong, I'm sorry, but I think it's about 65 gigs. So we now know basically how to choose our instance. We go back to deploying our single endpoint. We say, okay, fine. We're using our single endpoint. We have a Llama 2 sitting inside an instance. But then we want to scale it because, again, we're getting a lot of calls in our call center. It means we have to spin up another container. Even if you're missing out on being able to run Llama again on that instance by like 1 gigabyte, you have to spin up another one, right? So it can be a bit wasteful, but you have those instances running inside your SageMaker container. And what that means is that basically your users can query that and they can stream that. But remember, we're not just dealing with Llama, right? We are dealing with a few things. So we want to actually scale this to multiple models. We start thinking of like having that endpoint that can scale to multiple instances for our Llama model. And then we have to do the same thing for our text-to-speech and our speech-to-text endpoints. And let's not forget our knowledge base. So we have to do the same thing for our embeddings as well. So what this means is that it's high operational overhead and cost, which is against the spirit of this talk. So that's not what we're going to do. So you might ask yourself, can we just host all of them on a single endpoint so that I don't have an endpoint for each? Yeah, we can, right? And I'm specifically very proud of that animation. I learned PowerPoint last week. So you can do that. And what that looks like internally is that you've got some smart routing that's happening. So as you get requests, the SageMaker endpoint is able to kind of route to the right container. And it also means that you get dynamic model placement. Remember I said before, you might not be able to kind of like put your containers where they want to be. But the problem with that is that, let's say by some miracle, the only thing that's working in terms of your models is Llama, right? Because instead of using it for the call center, your IT department was smart enough to create the chat interface for the people in the company. So they basically using that as opposed to ChatGPT. So you find that being your only model that's up, it means that when you do receive that call and you need to basically spin up your other models, you're going to experience cold starts. It means that like the model has to basically be placed. You do get dynamic placement, so that's great. It's going to get placed in an instance. It's going to have to download the model weights. It's going to have to warm up the model as well, meaning that you're basically going to get like a whole lot of latency before answering. And if I'm calling the call center, already pissed off because I've got double billed, that's just going to make it worse, right? The plus side of this is that it's cost efficient. It scales to multiple small models, right? It might work quite well for small models, but which can start up relatively quickly, and you can basically, shoulder the call starts, and you get dynamic model loading and unloading, right? Meaning that you get some kind of caching if a model has been up. You don't experience those cold starts. But the problem is that, again, if a model has not been invoked for a very long time, you kind of experience those kind of things. And then it only has support for a single CPU. So again, making our options not feasible for what we're trying to do. And this is the same problem that Conjecture had. And luckily, we're lucky enough to work with AWS to feedback on the problems that we're having. We're finding workarounds. Those AWS credits, so it was okay while we're still building, but it wasn't feasible for production. But at the same time, AWS was taking a lot of feedback from their customers and built a custom new thing called inference components, right? So much of the same thing. So you still have a single SageMaker endpoint, like the previous one we looked at now. Within that endpoint, you might have multiple instances, and everything else, the autonomy looks the same, right? Because you might have multiple instances. Each one has like a container. So you provide like where the location of the container. So this AWS uses Elastic Container Registry, which is basically Docker Hub, but in AWS, because security and things, right? And then your model artifacts will still be sitting in S3, as we've discussed before. You'll still be able to basically configure your hardware requirements, the number of CPUs you require for your model, number of GPUs, max and min and max memory, as well as the number of copies that you need for your model. You might need a bit more copies for your LLM as you would, for example, maybe your text-to-speech. So you can configure that individually. The one thing that changes is that with the previous models, with the previous methods, you'd have to scale each instance, right? Even if some of it is not used. The difference here is now basically they've provided scaling policies at a model level, right? So you can scale on basically, like time of day. It's weekend, you don't get a lot of calls, so you can scale down your model that way. But you can also scale it up and down based on the number of people that are currently interacting with your system at the time. So what that looks like is like, for example, again, there might be a bit more of a need for your Llama model than there would be, for example, your speech-to-text model. So your endpoint determines that, okay, fine, for me to have 3 copies of Llama, because each instance has 4 GPUs, I can put in a Llama model on one instance, have 2 copies, on the other, and it also means that you still have space for a model that might require only 1 GPU in there. So, excuse me, if you needed another copy of the speech-to-text model, it means that you still have space in there, right? The nice thing about this is basically that if, for example, something happened, again, it's the time when people are not requesting so much, you could basically kill that other model, and things can work within one instance. So you kind of get smarter scaling and better placement of your models. This currently doesn't scale down to 0, but they promise that they are working on it, on scaling that down to 0. So, come to my next talk. We'll talk about scaling to 0 on SageMaker. Cool. So to recap, also check, still on the same page. For our deployment method, we've chosen real-time. For our hosting, we've chosen SageMaker. And for the type on SageMaker, we've decided to choose inference components. So what's left is for us to actually go and deploy, right? We've kind of gone through all those choices. So the first thing is that, again, we need to go and pick the instance that we have. So we've done our calculation. We know what instance that we want to host on. The second point is you need to go create something called a SageMaker endpoint, which, so the endpoint configuration basically says what's required. The endpoint itself will be the physical thing that goes and gets created with those requirements. And then after that, you basically just go and deploy your model to the endpoint using inference components as we've chosen, right? So couldn't finish the talk without some code. So what that looks like, for example, I've chosen Python because machine learning, right? So what that might look like, you might go and use something like Boto, which is an AWS SDK. By the way, you can do this on the console using ClickOps. You can go and create a model configuration. You can do this using the AWS CLI. You can do it using the SDK. You can also do it via REST. The only thing is that if you use a REST API, it means that you have to sign the AWS request yourself. If you ask ChatGPT, it does actually a good job of generating whatever code to sign AWS, and you'll know it works because AWS lets you actually make the request. So what you're looking at there, where we're creating the endpoint config, we go and you can have multiple variants. So it's beyond the scope of this talk, but you can have things like a shadow variant. You might be doing a variant that's internal to be doing some A/B testing. People typically do that, but you might have one like for all traffic. You go and basically have your instance type based on your calculations that you want to host for that. And then, so you might need a bigger instance, for example, if you want to host multiple models. And then you basically want to go and say, okay, what is my initial instance count? So, very small shop, you're trying something new, you might say 1. But if you're very established, you might say, actually, to start, I might need 3 or whatever. So that's configurable in there. And then you need to go and basically configure your routing config. So to say, how does SageMaker make a decision on which, like model to send or instance to send traffic to, or to send to put your models, and you go say, fine, list, outstanding requests. So the one that is, not very busy. Cool. So the first thing, create our endpoint config. The second thing that we'll be doing is creating our SageMaker endpoint. And that's the easiest part because we just basically pass a reference to the config and give the endpoint a name. Again, you can do it on the CLI, SDK, or REST. 3.1, yeah, there are kind of 2 steps. You have to prepare your model. Remember, I said you don't even have to go and build your own container. So there's a very nice service called Hugging Face. It's basically GitHub for machine learning people have got a really nice logo. It's like a hugging face thing, right? So you can go and basically pull that. As you can see, the framework that we're using there for Hugging Face, you have to go specify whatever version of Hugging Face you want to use, and then basically you'd go and say, I want the llama, this llama model from Hugging Face, and set whatever other environment variables that you might need. Cool, almost done. And then, of course, the last thing that you'll do is you'll actually go and you create your model. Once you're done creating your model, so now you've got your endpoint config, you've got your endpoint, and you've got your model created. It means that you can go and create your inference component, right? So basically saying, go and put this model in this place. So that, again, give it the model name, the number of things like the CPU cores that's required, and all of that. And lastly, you can run the inference, right? So you can invoke it. So you can invoke it by passing in the name of the model that you've just deployed, and really everything else is like your query, like why does Lucky always talk about bananas, and that's going to give you your response. So again, to recap, we've chosen real time. We've decided to use SageMaker, and because the nice people at AWS listen to us, we decided to use inference components. And again, that means that basically you have your models running in a single SageMaker endpoint, and people can request it, and you can even stream back the responses. And this time, the streaming I'm talking about is the streaming of the typing thing that you get of ChatGPT. And that's all you need to do. So what now? you can go forth and build your super app and profit. Thank you. Do you have time for questions, or did I run over all my time? Cool. You can find me outside, and I'll finally have a beer, and I'll answer your machine learning questions.